Our next speaker, David Lohr, is the pavement management engineer with Washington State DOT. He's got a bachelor's degree in civil engineering from the University of Illinois at Urbana and a master's and PhD from the University of Texas at Austin. So just like Charles, you'll be hearing another guy with a Texas accent coming up to us. Yeehaw. So David joined WSDOT in 2007 and has a background with 40 years experience related to pavement engineering and asset management. He's one of my go-to guys for pavement management. So thanks for coming to the conference. Please welcome David Lohr. Thank you. Thanks. Oh, I got to make this happen.
So I'm going to talk about performance measures and some of the experience we have at WSDOT with using a variety of performance measures for different reasons. And so I'm going to cover a wide range of purposes. But we like to look at performance measures as tools. And there's a variety of different categories that we can put these tools in. One is decision support. So with pavement preservation, the where and when of the preservations is very important, and so we can use measures to help us make those decisions. And then we have to be accountable to others, to the legislature and to the public. We have to communicate. So there are good performance measures to do that. Forecasting needs and risks. There are other types of performance measures to do that. And we also want to be able to learn from our experience. And so those are some other performance measures. So we could look at these in different categories, and so I'm going to go through some examples. But when we look at performance measures, we can consider, well, what context are we evaluating? Are we looking at historical? Or are we projecting into the future? Is this a project level or a network level evaluation? And is this an agency perspective or a user perspective? And the answer is yes to all of these. These are all possible ways of looking at performance and measures and helping us to make decisions. So I'm going to start off with some examples. Some of the oldest performance measures that we've used as pavement engineers go back to the ASHO road test in the early 1960s with cracking, rutting, raveling, faulting, and pavement profile. So we were one of the early engineering disciplines to use performance management with the present serviceability index. So over time then, we've continued with that. In the 1980s, we developed the IRI. There's friction measurements and structural measurements. So really, performance management is ingrained within the pavement management discipline. Now, most of those measures relate to the agency, but how's the road performing for users? They're the ones who are paying for it. So roughness is a big one, and that interacts a lot with user operating cost. There's also user delay cost, freight damage, safety. So there are more performance measures then that we can look at from the user point of view, but we have to realize, well, what's the end result and why are we using these particular measures when we're doing them? So with MAP 21, we know that with MAP 21 we're going to be doing a lot more performance management. And this is from Title 23, where MAP 21 resides in the US Code. Performance management will transform the federal aid highway program. And then it also says, and provide a means to the most efficient investment of federal transportation funds. But there's nothing in the MAP 21 performance measures that relate to the most efficient investment of federal transportation funds. There is in the asset management part, we need to develop an investment plan, but in the performance measures part, there's nothing to show Congress, well, have we really done the most efficient investment? So I think we will see that over time. And then this is something that we've been using at Washington for several years now, and that's cost effectiveness. This is our real workhorse for performance measures. And the units of dollars per lane mile per year is a very nice common denominator to look at comparing different treatments, different performance, to look at prioritizing projects into the future. So we use this a lot. Now I've underlined acceptable. So we've done a lot of simplifications with these performance measures, and this is one of them. Instead of looking at a cost benefit analysis where we try to quantify the benefit of better performance, well, it's very difficult to put better performance in terms of dollars. So instead, we just say we have a criterion for acceptable performance. As long as the performance is acceptable, so we have cracking, rutting, roughness criteria to have acceptable performance. Then our only objective is minimum cost. So that's our main criteria, our main goal. So in order to evaluate the most efficient investments, this annual cost term, dollar per lane mile per year, is what we use most of the time. We use this to prioritize projects. We use it to evaluate historical performance. And so when we're looking at the future, then that's more of our traditional life cycle cost analysis, but we always do it in terms of annual cost. So the annual cost is pretty simple to calculate. Many are more familiar with net present value in the real cost software, but annual cost is just a simple transformation from net present value. But the advantages of using annual cost is it's simple. You can directly compare two different strategies. If you have one strategy that's 15 years and another strategy is 25 years, you can compare those on annual cost. It's a lot easier than using net present value. And you don't need to consider salvage value, so there are some simplifications. So if we look at some examples, now these are not meant to be comprehensive. These are just examples of kind of how we break down our evaluation of annual cost. And our pavement types, 3 basic categories: chip seal, asphalt, and concrete. And within each of those pavement types, maintenance, rehabilitation, and reconstruction. Concrete is a little different, and given the time constraints, I won't go into how we look at concrete separately. But within each of those treatments, we have an estimated life and a cost. So it's very straightforward to calculate the annual cost. And over on the right-hand side, there's 2 columns, one with the annual cost with a 0% discount rate and one with a 4%. So we calculate it both ways, basically to look at the range. Most of the time, it doesn't have much of an effect, but we do it that way for informational purposes. We do think it is important to use a discount rate. So when we look at that, comparing the annual cost of maintenance versus rehabilitation, we see that maintenance is usually 5 to 10 times less expensive on an annual cost basis than rehabilitation. So we should be trying to do maintenance or preservation as long as we possibly can until the pavement will no longer be as suitable, for that kind of treatment. And then avoid reconstruction as much as possible. So I'm not going to cover this curve in detail. We've seen many versions of this. But as we look at the different treatment options as we go down the performance curve, we start off with preservation. We try to do that as much as possible. And then rehabilitation will be delayed when we do those preservation treatments, and that helps our annual cost as well. So not only is preservation cheaper on an annual cost basis, it also improves the annual cost between rehabilitation treatments. What we really want to do is stay away from the lower part of that curve, below the optimum time for rehabilitation, because the reconstruction costs are very high, but also the user costs are very high when we get to the conditions that are very poor. And we've been very successful at doing that. We haven't done, for our flexible system, we haven't done any reconstruction for decades. We've been able to keep all of our flexible system above that line, and it makes a big difference. So in order to do evaluations then, of well, when am I at a point where I need to do a rehabilitation, there's a process in decision analysis called replacement analysis. So we basically compare the annual cost of my current treatment versus the annual cost of any other treatment that could be a replacement. And as soon as it is lower in cost, well then I should change. So with this graph in the blue line, the annual cost will continue to decrease year over year just because we're dividing the initial construction cost by more years. So the annual cost is on the left axis. The annual cost will keep going down as we get more and more years. But as time goes on and we do more and more maintenance and we need to do more and more treatments, well then that cost will begin to increase. So the green line is the total cost, the sum of the maintenance and the agency construction cost. And so we get that low point where this is the optimum time for change because our annual costs begin to increase. So the bottom of that is really defined as the economic life of that treatment. So we could look at a couple of examples. We have an initial cost of, say, $250,000 for a rehabilitation. If it lasts 12 years, the annual cost is $26,600 and some. But an alternative treatment would be, instead of going 12 years, if I spent $5,000 per lane mile in year 10 and another $15,000 per lane mile in year 15, I can extend that to a 15-year performance period, and it goes to $23,000. So I spent money, but because I've extended the life, I've reduced the annual cost, and I've actually had a 12% reduction. So those are the kind of trade-offs then that we can evaluate, and we can do a break-even analysis to say, well, how much money could I spend in year 13, say, in order to get that to 15 years? And I could spend $70,000 a lane mile and still break even. So this way I can evaluate the trade-offs of different treatments and see where the break-even is. If I know where the break-even is, even though I don't know exactly how long this is going to last, I don't know if it's going to last 15 years, but I know that if it lasts 15 years, what the break-even value is. So that helps me in my decision process. So we've looked at mostly to now just performance measures for decision support. But as we begin to look at other uses like accountability and communication, how can I use those measures better? So this is going back to the same annual cost, but looking at it on a region level. We have 6 regions in Washington. On the right-hand side is the statewide average. And we can see that for urban areas in blue and rural areas in red, we can calculate the average annual cost that we have per lane mile. But what we found is that there's not a lot of great information for decision making here. We could have targets that we give to each region, and on the region average, this is really what you should be working toward. And we can see if one region does a lot better than another, but you can see from this plot that it's all pretty average. But when we drill down further into these numbers, this is an example of looking at just one region. And there are many projects within that region. So I'm not going to go into this in a lot of detail, but over on the right-hand side, that's that statewide average with the red bar around it that we saw on the previous slide. But there's a tremendous amount of variability within that one region. Looking historically, looking back, how good of a job have we done in managing our pavements? So we can look back and see, well, we can calculate exactly what the annual cost is because we know what the original project cost and what we've spent over the years. Now the little green triangles indicate lane miles because sometimes we'll get a spike, a really high cost, but that's because there's a very small number of lane miles. Maybe we're just doing an intersection, an interchange. Maybe those are ramp costs and maybe they're a lot higher because our traffic control and we're not doing a lot of lane miles. But we can see that there are some projects that have really high costs. Well, within WSDOT, lean is a very big process that we're going through. And a big part of lean is continuous process improvement.
What's lean?
Okay, I'm sorry. Lean is a method to evaluate. There's no acronym for lean, sorry. But lean is a process to evaluate methods and try to make improvements in efficiencies everywhere you can. So it's a basic business management process that sometimes agencies become enamored with, and our agency is enamored with it. So this business process then really emphasizes continuous process improvement, where you do something and then you evaluate how well it's done and then remember that. So we can see which projects were really poor performers. Maybe it was constructed late in the season. Maybe it was not the right design for the system. Maybe we just had poor construction. And then we can see where we've got really low costs on an annual basis, and we should try to see, well, what have we done right? And try to replicate that in other places. This is a little different example where we've looked at annual cost by location. So as we go down the road, we can try to locate areas where we have costs that are out of the ordinary, or maybe costs that are better than normal. So on this plot, this is a screen plot from our pavement management system. And you can see that their costs are really high at a certain location. And then underneath that location that's circled, we can see a list of construction activities that occurred there. And we can see that we had overlays, 2-inch overlays there in 1996, and 4 years later in 2000, and then 2 years later in 2002. So we're spending a lot of money in that location, but this chart really brought it to our attention. So we need to investigate that, and as it turned out, that's on one of our routes that's in an area with unstable slopes. So sometimes every couple of years the slope will move and we'll need to go in and reestablish the proper profile. But it tells us how much money we're spending to do that, and maybe it would be a good investment if we go in and try to stabilize that slope, depending upon what the exact situation is. So this gives us the information available to see what we're spending now, and then we can evaluate it with other alternatives, but it gives us a really good way of evaluating it. So those are all project level where we've really been able to use annual cost, but what about the network level? Well, a few years ago we developed some new network level performance measures, and I'll go over 3 of them: remaining service life, asset sustainability ratio, and deferred preservation liability. So the first is remaining service life. Many of you are familiar with this. The FHWA has evolved to remaining service interval, which is fine. It's basically the same concept where we're looking at, for any individual pavement section, how much time do we expect until we need to do rehabilitation? And then we could determine that also, or express it also as a percentage. So if we typically have a 20-year pavement life and we've gone through 10 years, we could say we've gone through 50% of the pavement life. Now, if we roll those numbers up for every section in the network, well, then we can look at a network level remaining service life, and our target there is to have a network wide of about 50%, or a range of about 40 to 60% that we want to stay within. So on this plot, we've looked back historically, and I'll explain why that this is kind of cut off between 2012 and 2013, where the colors changed to red, and those are projections. Well, what we used this information for was to explain to our executives and the public and the legislature what was going to happen if we had some real serious decreases in our budget. Because that was the plan. As many states, we went through a lot of tough times, and we had plans for really drastic cuts after 2013. So we showed that we had a drop in remaining service life of 18% over one 10-year period, but looking out for the next 10-year period, it was going to get a lot worse. So we wanted to emphasize the fact that we were not really doing, this budget that was proposed was really going to cause some serious long-term permanent harm. And at the same time, the DOT was proposing a fuel tax increase. And so this was part of the effort to explain why we needed a fuel tax increase. And this information is published every year. We have a performance management publication called the Gray Notebook. You can look that up on the internet, and it's for all of our departments, from bridge to safety and pavements. But we've got information there, and so this is one of the communication tools that we use to include in that document. The second term is the asset sustainability ratio. This we borrowed from or stole from the Australians. And this basically looks at how am I replenishing the life of my system. First, I measured assets. First, I measured remaining service life, so I know how much life I've got left. But what's my track record of replenishing the life? And the units are lane mile years. So if we have an 18,000 lane mile system, I go through 1 year, I've consumed 18,000 lane mile years of life. But how much did I put back? Well, if I have a 10-mile chip seal, I plan that it's going to last 10 years. Well, I've just taken 10 times 10, or I've just invested 100 lane mile years back into the system. So every year, then we can, in this case, I'll show you the chart, but our target then is 1. We'd like to see as much replenishment as we do consumption. So we were able to go back to 1980 and look at the trends there of how much that we're taking out, which is always, well, in this case, this is only our flexible pavement, so it's 16,000 lane miles per year. And then the replenishment. And you can see for 30 years, there was pretty reasonable replenishment. There were some peaks and valleys, but overall, that's not too far from 1. But then we saw the projections and how it was going to be drastically decreased. So we were able to communicate that we're getting into territory in the next 10 years that we've never been in before. And the third term was deferred preservation liability, where we try to calculate the dollars that it's going to cost us to, it's basically a backlog liability term. Because if we defer a project, we're not necessarily, quote, saving any money. All we're doing is carrying a liability forward. And this is a term that helped us add up those accumulated liabilities. And over time, they increase. So if I could have done a treatment, this year and I didn't, well, next year it's going to cost so much if I try to do it next year. But if I wait 5 or 10 years, I'm going to have to spend a lot more to do what I could have done this year. So it includes really a penalty then of the additional cost of deferring that job till it gets to a more serious situation. And then that really ramps up to huge expenditures that include the cost going forward. So I guess the good news is our gas tax passed. It took a couple of tries. I don't know how much credit we can take for it. Maybe we helped a little bit. I don't know how much legislatures pay attention, but at least we were able to communicate our perspective on what we felt was going to happen. So to summarize, there's a variety of different performance measures that we can use and implement. We can put them into different categories like decision support. And we can look at the context of whether that's in the future or if it's historic or if it's at the project or network level. But we should be designing performance measures to meet our needs, and you can use your imagination, and there's a lot of different types of performance measures that are good for different purposes, so we're not just stuck with 1 or 2. There's lots of them, but there's a lot that we can do under the whole area of performance management. So that's all I've got.
Thank you. Any questions for Dave?
The question was, this is one example of looking at our annual cost at a particular location. But yes, and it's all automated now, so it's really pretty easy. So that anywhere in our network, every year, it will recalculate what the annual cost is based on the historical cost and the expected life of that particular section. So that, yes, we have it everywhere. So we could pull up this same kind of a plot anywhere on our network in our pavement management system.
But is it programmed to flag them?
No, not yet. We should have, right now we have, it's a manual process, but that's a good idea.
So I want to ask you, WashDOT started your pavement management system in what year?
Oh, about 1975.
Yeah, so they've had the same pavement management system for that many years, so almost 40 years. So they have a plethora of historical data that many of us don't have access to. So WashDOT's in a great location to be able to do these sorts of analysis, and hopefully over time, as more and more of us get consistency in our data and acquisition, we'll be able to use these sorts of tools. And really, I hate to say it, but MAP 21 is sort of forcing the performance management issue onto the states. And I think a lot of the issues that we have, and I've said it before in public forums, but yeah, it's a failure of management. We need to, we're being paid a lot of money to manage these systems. We have to manage it for the good of our nation. It's got to be done. And we're tipping right now at a very difficult time. We can't afford to go back in and rebuild all these things. So I loved your presentation. Other questions?